Hi, I'm Herb Gross, and welcome once again to our Math as a Second Language video series, where today we're going to talk about adding and subtracting mixed numbers. And again, I'm going to do the same thing, same routine as I did when we were introducing the arithmetic of common fractions. Going to be able to show you that in terms of the adjective-noun theme, if you replace the fractions by pieces of a cornbread, the problems suddenly become a whole number of problems again. And to keep within the scope of my feeling that it's okay to use the traditional recipes, algorithms, provided that you understand them, let me start by doing a problem the purely mechanical way, the way I was taught. Let's look at a problem like 6 2/3 plus 3 3/4. And in a sense, once we knew fractions, we can think of going mixed numbers as being a new language. In other words, any problem that involves mixed numbers, we can now rewrite, based on our previous lecture, we can rewrite them as improper fractions. And since we know the arithmetic of fractions, we can solve the problem as a fraction problem. And then once we have the answer as a fraction problem, we can translate the answer back into a mixed number problem. So let's just take a look and see how that might go. Suppose I want to add 6 2/3 plus 3 3/4. Again, in my mind, the 3 tells me I'm thinking of a cornbread that's sliced into 3 pieces, 3 equally sized pieces. So if there are 3 pieces per cornbread, 6 cornbreads will be 18 pieces, plus I have 2 more of them. So it's 20 of what it takes 3 of to make a cornbread. I don't even have to know that. What do I do mechanically here? 3 times 6 is 18. 18 plus 2 is 20 over 3. 4 times 3 is 12, plus 3 is 15 over 4. And now I've translated this, even if I have no idea why this works. Now I want to add. But I already know I can't add fractions unless they have the same denominator. I can add them, but I can't add the numerators unless they're modifying the same denominator. So with 3 and 4, I pick 12 as the common denominator. 3 goes into 12 4 times. 4 times 20 is 80. So 20 over 3 is the same as 80 over 12. 4 goes into 12 3 times. 3 times 15 is 45. So 15 over 4 is the same as 45 over 12. Now the denominators are the same, so I can add the numerators. 80 plus 45 is 125. Common denominator is 12. So a correct answer is 125 over 12. But why can't I accept that as being the correct answer? Because since the problem was worded as a mixed number problem, I have to give the answer as a mixed number problem, okay? In other words, if I were to write this, the noun on this side is cornbreads, the noun on this side is pieces, and we said what in our earlier lectures? You can only compare the adjectives if they modify the same noun. So what do I have to do now? Well, in the previous lesson, we also learned how to convert an improper fraction into a mixed number. And how do we do that? We just took the 125 over 12 and brought the numerator down. 12 goes into 12 once. There's no remainder. You bring down the 5. 12 goes into 5 0 times with a remainder of 5. 5 what? 5 of what it takes 12 of. And so the answer is 10 5/12. I don't know whether I made a mistake or not, but I can get a gut check. I know that the answer has to be bigger than 9, because 6 plus 3 is 9. 6 2/3 is bigger than 6. 3 3/4 is bigger than 3. When I say bigger, I mean greater, really, because, I can say that 3 is bigger than 4 in terms of the numerals. We really should use the words greater and less than rather than bigger and smaller. But we can use what we're used to as long as we understand what the words really mean, okay? And that's the answer to the problem. In other words, the answer is 125 over 12. If the noun is pieces, it's 10 5/12 if the noun is cornbreads. Now, let's see how we can get this just by understanding our Cornbread model. The Cornbread model is going to solve a whole bunch of things for us. And remember I told you at the beginning, I'm not here to tell you to give up everything else that you're doing and just use the Cornbread model. All I want to show you is that this is one more tool that you might find that helps your students. And as I may have said also in my opening lecture, my hope is that not only will that be true, but that you'll actually agree with me and see that this one concept, the Cornbread model, unifies all of the math that you have to know. You can do all of the arithmetic, whole numbers, fractions, decimals, percents, in terms of the Cornbread. And that's what I really want to emphasize. So let's take a look and see what this problem really said. When you're adding 6 2/3 and 3 3/4, it doesn't matter whether they're whole numbers, common fractions, mixed numbers. You can only, what was our rule? Whenever you added them, you assume they were modifying the same noun. That noun will always be represented by the cornbread. This indicates to you that you want the cornbread to be divided equally into three equal parts, so you want the number of pieces to be divisible by 3. This says you also want it to be divisible by 4. It's the same cornbread. How can it be divisible by both 3 and 4? Well, 3 times 4 is 12. So let's assume that the cornbread now is 12 pieces. So the noun is cornbreads. What do you have? You have 6 whole cornbreads. Well, if each cornbread is 12 pieces, 6 cornbreads is going to be 6 times 12. Again, notice a whole number problem. That's 72 pieces. A third of the cornbread, a third of 12 pieces is 4. So 2/3 is going to be twice 4 pieces, which is 8 pieces. So 6 plus 2/3 of a cornbread is going to be 72 pieces plus 8 pieces. So if the noun is pieces, you no longer have a mixed number. See, what is 6 2/3 cornbreads is what? 80 pieces, which is a whole number. But the problem was stated in terms of cornbreads. I'll use CB. So what must the answer be modifying? Also cornbreads, not pieces. But how many pieces does it take to make a cornbread? 12. So each piece is one of what it takes 12 of to make a cornbread. And isn't that exactly what we did when we said 3 times 6 is 18 plus 2 is 20? That's 20 over 3. Multiply numerator and denominator by 4. That gives you 80 over 12. Notice that once, this is my claim, once you've gone through this, it should be very easy to abstract into this, saying, I don't have to write the cornbread anymore. I can write whatever noun I want. And just to prove that, let me replace the cornbread. See, what else comes in 12s? Dozens. Let's suppose the problem was 6 2/3 dozen donuts plus 4 3/4 dozen donuts. Well, again, there's 12 donuts in a dozen. So 6 dozen donuts would be 72 donuts. 2/3 of a dozen donuts is still 8, so it's 80 donuts. The same 80 we had before. But now instead of saying 12ths or pieces, we're saying donuts. And 3 3/4 dozen donuts, well, every dozen is 12 donuts, so 3 12s is 36. 3/4 of a dozen is 9. 36 plus 9 is 45. So the problem is 80 donuts plus 45 donuts. That's 125 donuts. The problem is the addition was given with the numbers modifying dozens, so the answer has to modify dozens. How do I convert 125 donuts into dozens? Well, there's 12 donuts to a dozen. I take the 125, I divide by 12. And did you notice that this was step by step exactly the same as what we did with the cornbread? And you said, yeah, but what if something wasn't divisible by 12? It doesn't matter. It doesn't matter. Pick as many pieces as you want. I'll give you another example. Let's suppose I want the noun to be hours. How long is 6 2/3 hours plus 3 3/4 hours? In other words, if I worked 6 2/3 hours one day and 3 3/4 hours the next day, how many hours did I work altogether? Well, let's convert this to minutes and we'll get rid of the fractions. There's 60 minutes to an hour, so 6 hours would be 360 minutes. A third of an hour is a third of 60. 60 divided by 3 is 20. So 2/3 would be 2 times 20. That's 40 minutes. So 6 2/3 hours is 360 plus 40 minutes. That's 400 minutes. 3 3/4 hours, well, there's still 60 minutes to an hour. 60 times 3 is 180. 3/4 of an hour. A quarter of an hour is 15 minutes, so 3/4 of an hour is 45 minutes. So 3 3/4 hours is 180 plus 45 minutes. That's 225 minutes. Now, instead of dealing with mixed numbers, I'm dealing with whole numbers. 400 plus 225 is 625. Whenever 400, 225, and 625 modify the same noun, so the answer is what? 625 minutes. And notice that as long as I'm allowed to use the nouns, I can write this, because people can see right away that here are minutes and here are hours. The problem is, if I leave the nouns out, now I have the problem that the nouns have to be the same. And again, just as a check, 625 minutes, there's 60 minutes to an hour. So we'll divide 625 by 60 and see how many hours that is. 60 goes into 62 once, that's 60, leaves 2 left over, bring down the 5. 60 doesn't go into 25, so it's 10 with a remainder of 25. 25 what? 25 minutes. That's 25 sixtieths of an hour. 25 sixtieths reduces to 5/12. Divide numerator and denominator by 5. There's the same answer that we got before. Now, once we've done a couple of examples like this, I don't think there's any hardship. And again, these are just my own opinions. Remember what I said at the beginning? I will tell you what I think is important and why I think it's important. And your share of the responsibility is you will decide where you agree with me. You don't have to agree with me. But wherever you do agree with me, you will be the one who's responsible for figuring out how do I tell this in an age-appropriate way to the students that I'm working with. Because I'm not good at that. I've never worked with students at that age, okay? So anyway, let's assume now that the person has done enough of these problems with the nouns present. Is it now relatively easy to say, well, 6 2/3 plus 3 3/4, I'll just add these. And how do you add? I'll add the whole numbers, and then I'll add the fractions. To add 2/3 and 3/4, I have to get a common denominator. Common denominator is 12, so I'll rewrite 2/3 as 8/12. I'll rewrite 3/4 as 9/12. 6 8/12 plus 3 and 9/12. Well, 6 plus 3 is 9. 8/12 and 9/12, see they're modifying the same noun, is 17/12. Well, if it takes 12 to make a whole unit and you have 17, you have enough for one more whole unit plus 5 left over. There's the answer. And if you want to do it in terms of pieces again, as we did before, the 6 2/3 is just another way of saying 20/3. The 3 3/4 is another way of saying 15/4. Okay? And now you just get these over a common denominator, and that's the same thing that we did before. And again, you begin to see the uniformity, that by dealing with quantities instead of numbers, we can manipulate so that any problem that involves numbers other than whole numbers can be converted into an equivalent problem that uses only whole numbers. There's nothing new that happens in fractions once you learn that the denominator represents the denomination and the numerator is the adjective, okay? And once you know how to add, subtracting is just on adding. So I'm just going to do one simple problem that way to have you see how that works. Suppose instead of adding 6 2/3, I want to subtract 6 2/3 and 3 3/4. I want to subtract 3 3/4 from 6 2/3. Well, in terms of the cornbread model, nothing has changed. 6 2/3 cornbreads are still the same 80 pieces. And the 3 3/4 cornbreads, okay, they're still 45 pieces. And 80 pieces minus 45 pieces is 35 pieces. but it takes 12 pieces to make the cornbread. So to convert 35 pieces into cornbreads, I have to divide 35 by 12. Well, 12 goes into 35 twice with a remainder of 11, so the answer would be 2 and 11/12. Okay? And if I wanted to do this in terms of improper fractions, notice it's exactly the same as I did over here. I do exactly the same thing that we did previously. The only difference is that wherever I had a plus sign here, I now have a minus sign. So I still get the 20/3, I still get the 15/4, but now I'm subtracting them. So I pick a common denominator, that's 80/12 minus 45/12, 80 pieces minus 45 pieces, that's 35 pieces, 35/12, that's 2 and 11/12. And if I wanted to do this using only the mixed numbers and not going through the second language, if I didn't want to use improper fractions, what would I do? I want to subtract 3 3/4 from 6 2/3. Again, I do exactly the same thing as I did before. I rewrite the 6 2/3 as 6 8/12. I rewrite the 3 3/4 as 9 9/12. The tricky part now is, whereas I could add 9 to 8, I can't subtract 9 from 8 because I don't have enough. So just as with whole numbers, to subtract I have to borrow. Here's the tricky part. Here's the danger. Most kids are tempted, when they do this, to put a 1 in front here, because that's how they were taught when they were dealing with whole numbers. And the reason that was the case is you were trading in by 10s. Now you're trading in by 12s. See, how many 12s does it take to make a whole unit? If you cut the cornbread into 12 pieces, how many pieces do you need to get the whole cornbread? You need the whole 12 pieces. If you want to exchange $1 for quarters, they don't give you 10 quarters, they give you 4 quarters, because it only takes 4 quarters to make $1. The thing you have to remember is, when I borrow, the one that I use has to be expressed in terms of the same denominator that I'm using here. In other words, the 6 is being converted into 5 plus 12/12. So the fast way of doing this is when you borrow and you're dealing with fractions, the new numerator is the sum of the original numerator and the denominator. See, it's the 8 plus the 12 pieces you traded in for. In other words, the tricky part is what? You don't write this as 5 and 18/12, it's 5 and 20/12. This is still 3 and 9/12. Now you subtract 9 from 20 is 11. There's your 11/12. 5 take away 3. Meaning, what do you have to add to 3 to get 5? That's 2. There's the same answer. And again, are you beginning to see the logical flow that I can translate every common fraction problem, every mixed number problem, into an equivalent whole number problem? Okay? And so now you see there's a unity. I think I told you before that the word calculus comes from the Latin meaning stone. In the same way that you have English 1, English 2, English 3, English 4 in school, you can have, you can have calculus 1, calculus 2, calculus 3, calculus 4, where each course flows logically in a seamless way from the previous one. And I think that's enough of a sermon for today's lecture, so let me now come to our practice problem that signifies the close. Our practice problem, remember, you're going to focus on the problem, you pause the video, okay, and you just read the problem, work it out, and then once you've worked out the problem or given up on it, whatever you want to do, you come back and watch how I solved it. The problem says you need 10 1/4 linear yards of a certain cloth. But by the way, the reason I put the word linear in here is you don't buy cloth by the yard, there's an area to it. And so it usually comes in a certain width. So if the standard width, say, is 36 inches, and you say, give me 2 yards, it's 2 yards by 36 inches. So that's what we mean by linear yards. I just put that in to avoid confusion with language. But you need 10 1/4 yards of that cloth. You have 3 3/5 yards on hand, and your friend gives you an additional 2 3/4 yards. And the question is, how many yards do you still need to get your 10 1/4? Okay? And if you're doing this problem, keep in mind, it's the same arithmetic you would be doing if these were whole numbers. The process doesn't change. It's only the adjectives are different. Okay? So let's take a look how that problem goes. You currently have 3 3/5 yards. That's what you had. Your friend gives you 2 3/4. So altogether you have 3 3/5 plus 2 3/4 yards. Okay? That means that to add these, you're going to need a common denomination. So 3/5 of a yard is the same. You want a common denominator to be 20 here, the 4 and the 5. So you rewrite the 3/5 as 12/20. You rewrite the 3/4 as 15/20. And so the problem is 3 12/20 yards plus 2 15/20 yards. Well, the 3 plus 2 gives you 5. The 12/20 and the 15/20 give you 27/20. It takes 20/20 to make a whole yard. So I have enough to make one more yard. Take away the 20 from the 27. So I have 6 yards plus 7/20 of another yard. But altogether, I need 10 1/4 yards. So to see how many I have to buy, I have to make up this difference. I have to find the gap. In other words, I have to find out what do I have to add on to 6 7/20 yards to wind up with 10 1/4 yards. Okay? And that's the same as saying what? 10 1/4 yards minus 6 7/20 yards. And notice again, guys, that I have to understand what is happening here. In other words, it's not enough to know how to add and subtract mixed numbers. You have to know which ones do you add and which ones do you subtract. The calculator can do the whole number process for you. It can't tell you which is the right methodology that you should be using to solve the problem. So anyway, to finish this problem off, all I have to do is to subtract 6 7/20 yards from 10 1/4 yards, and I'll do that without converting into 20. I mean, I'll just subtract using mixed numbers. So I'm going to take 6 7/20 yards. I can't subtract unless the denominators are the same, so I'm going to rewrite the 1/4 as 5/20. So I now have what? I have 9 25/20 yards minus 6 7/20 yards. The 9, take away 6. 9 minus 6 is 3. 25 minus 7 is 18. 18 what? 18/20. That reduces to 9/10. And so the answer to my problem was I need an additional 3 9/10 yards, which means in the real world I'd probably go out and buy 4 yards. Okay? Or 5 if I'm nervous and afraid I might waste something. But again, do you see the logical flow? I want to keep emphasizing this. That's the most important part. The how is the relatively easy part of math. The why is the more important part. And the beauty is that once you can see the why, the how becomes much easier. Anyway, again, that brings us to the end of today's lesson. I'm looking forward to seeing you all again next time. And until next time, be well, enjoy yourself, and see you soon.